Monday to Friday. 9 a.m. till 12 p.m. This is Today with Kino Kamis
on Cape Talk.
And it is time for us to talk to Dr. Chris Smith, the naked scientist. He's also one of the most personable people you would ever meet and has the answers to many, many questions that you might have. Chris, good to have you back, sir.
Oh, it's good to be here. Interesting times these, aren't they?
Yes, and just before we go to Ernie and Zanin, the suggestion has been to prevent the spread of COVID-19 instead of waiting for there to be enough cases in order to take action. And where does one, how does one actually balance all of this? Because you need an economy to go. You need young people to be educated. Universities need to educate. But at the same time, if you don't put all your preventative measures in place, while at the same time not causing panic, your economy could be harmed medium to long term.
People here are more divided than during Brexit over this, actually. It's really generating enormous amounts of dispute and debate about whether, say, the UK should do what many other countries in Europe have done, which is just to shut everything across the board, or whether to do what they're doing at the moment, which is a more staged approach. And actually, I keep saying to people, one, we have to be prepared for the ideas to change day on day because they're being informed by science and observation and direct measurements of numbers. And two, there is no rule book for this kind of thing. We're feeling our way through this because we've never been in this position before. So it's really difficult to know what precisely is the right approach. The strategy to shut everything is one approach, and in China that's the effect approach they've taken. But the thing we don't know, and everyone's watching to see what the outcome's going to be, is it's rather like parking your car on a hill and putting the brakes on. And if you then just take the brakes off, the car will start to roll down the hill again until the hill is sufficiently flat that the car won't roll. And getting the timing right so that when you do take the brakes back off again, there is no hill there or a much lower hill for the car to roll down. The hill being how many people in the population could catch this virus, that's really tricky. And so intervening at the right time to make your 2 weeks probably of meaningful intervention really achieve a big bang for its buck, that is really tough. And there are a lot of opinions about the best approach to this. Personally, I think that we must make sure we don't jump too soon. Other people think that many countries, including the one I'm sitting in, aren't doing enough. So I guess time will tell here, won't it?
Yeah, and I mean, you talk about the analogy of this hill. If there is a cliff at the end of this hill, you need to be sure that you get the roll and the runway right. And nobody knows.
But the other thing is one must not be so short-sighted as to see the end point just as people catch the virus and recover or catch the virus and die, because there are all kinds of other sort of channels the domino effect can go down. Because if you start, say, shutting schools, for instance, someone pointed out yesterday there are a very significant number of school children, even in the UK, for example, who their parents don't feed them properly. And if they don't go to school and get a free school meal, they really don't get fed properly. So arguably, is it better to keep their school open and make sure that a very significant number of kids get a decent meal? Or is it better to take them off school for 2 weeks and they'll probably end up malnourished? But they'll certainly won't eat properly for 2 weeks. Will we actually therefore see a net benefit? Similarly, if you take kids out of school, who's going to look after them? Well, maybe grandparents. So we want to get the more vulnerable members of society to now come and look after and babysit kids and potentially be more exposed to this virus, generating more cases in older people. So it's not simple. It's not a simple case of we do this and then this happens. It's very, very multifactorial, very, very hard to predict.
Absolutely. And as you said, no rule book. So let's go to Ernie and Zanin. Hi there, Ernie.
Hi there. Good, thanks.
So you have a question for the naked scientist, sir. We appreciate you calling in.
Yes, please, man. Congrats, Doc. Doc, 6 weeks ago I was working in the garden with in sandals. The next morning my foot, there was a blister in between my two toes. Anyhow, I went to the foot became swollen. I went to the doctor, and for 3 weeks he was treating me for athlete's foot. I've since realized that it's a spider bite, and I've tried everything possible. The swelling has gone down with his treatment, and tried dozens of things. Please, if you have any knowledge how to treat it.
Okay, so it's a spider bite that wasn't treated as a spider bite initially. Now, this is not normally about diagnosis and treatment, but I think Chris can maybe give some insights.
Hi, Ernie. As soon as you said the words open-toed sandals and garden, one immediately thinks of insects, not just spiders, but all kinds of things, creepy crawlies, including insects and spiders. I thought you were going to say something like an ant bite initially, but what could be happening here is that, yes, you could have had some kind of insect bite or a spider bite, and it's caused local inflammation, and now you've got a superinfection on top. By superinfection, I mean once you break down the body's best natural barrier, which is your skin, you're laid open to then entry by even low-grade, not very harmful bacteria, but because you've basically punched a hole in the castle walls, they can easily flood in. So there's a number of possibilities here. One could be ongoing inflammation caused by whatever bit you. That's certainly true because some of these venom chemicals cause a degree of local necrosis. Tissue breaks down for a while, and it takes a while for the protein that's causing that to be removed from the system and then the tissue to recover. The other is you should make sure you haven't now got some kind of bacterial infection, and this is a risk because if you've got a breach in the skin, you can sometimes, under certain circumstances, these infections don't stay localized. They can actually begin to spread, and you can get something called cellulitis, which is where the bacterial infection spreads through the skin. Very important if the area begins to get red and hot and swollen, and that it spreads a bit like the tide coming in up your leg. If you were to draw with a pen around the red margin, and then the next day it's moved a bit further and a bit further, that's actually potentially a spreading cellulitic infection, and you definitely should get that reviewed. But it does sound like some kind of bite by an insect or a spider of some kind, possibly with a superinfection on top. So I would make sure you, A, keep an eye on it, especially if you have something like diabetes, which might make this sort of thing of a higher risk. And B, if it isn't getting better, do go back and get more advice, because it may need further treatment, including some antibiotics.
Thank you for that, Chris, and thanks for asking the question there, Ernie. We go to Daniel. Daniel's in Fisher. Hi there, Daniel.
Yes, good morning. I just have a question regarding the amount of plastic that goes into the ocean every year. What I've always heard, you hear a statistic of 8 million tons of plastic per year, but I didn't really, it's difficult to get a vision of how much that is. So when I did a little bit of maths, with regards to the average density of plastic to convert it into volume. And what I calculated was that it kind of works out to be the equivalent to 1 drop of water in 3 Olympic-sized swimming pools. So it's, parts per trillion. It's very, very, in terms of the volume of the ocean, because the ocean is so big. So what I don't understand is, how is it such a problem if the ocean is so massive, and statistically, there's a small volume of plastic going into the ocean, but I mean, I know it's a problem, but I can't equate those two things.
Sure.
So if you could just illuminate that perhaps for me.
Well, I think one has to remember that size isn't always important. It is in many cases, but in some cases it's not. And for instance, you only need 1 or 2 coronavirus particles, which are 1/10,000th of a millimetre across, and it could bring down a whole human. So relative to the size of a human, yeah, you can see that size does matter sometimes, but not all the time. Now, in this context, you have to remember that part of the problem isn't just that it's a tiny amount of something. It's a tiny amount of something this year, next year, the year after that, and for years and years and years and years and years, and it's increasing. And the plastic, it isn't there and then tomorrow gone. It's there for a very long time, so it will therefore accumulate. That's the first point. The second point is the big threat with plastic isn't that when it goes into the sea as a plastic bottle, actually. It may be visually unsightly, but in fact that is not the major challenge. The major challenge is that all this plastic gets concentrated in various parts of the sea, rubs up against other bits of plastic, and the whole thing breaks apart. And it breaks down into tiny particles of plastic, initially very small bits, and then the small bits break down into even smaller bits that we can't see. They become so-called microplastics, and they do 2 things. One is that they pick up from the water of various toxic cargoes of chemicals that like to bind to oily things. 2, they become part of the food chain because they're so small, they're on the sort of size scale of the sorts of things that filter feeders tend to consume. And that means that they're going through these filter feeders and they're depositing their toxic cargo of oil-loving chemicals, which include things like PCBs and other things like pesticides, other organic molecules and persistent chemicals that don't break down easily in the environment, and they're depositing those into the bodies of the filter feeders, and the filter feeders become food for bigger animals like fish, and the fish become food for bigger animals like us. So there's a potential for this to catalyse the accumulation in the food chain of various nasties, as well as potentially directly poisoning creatures, because if they're eating plastic, they're not getting any calories from it, so they're therefore not growing because they're eating it. So they're wasting their time filtering out stuff and then throwing it away that doesn't help them to grow. So it could stunt the growth of the whole ecosystem, logically. So one has to be cautious just because there isn't a huge volume of something. And actually, I slightly dispute the calculation. I mean, the Earth is vast, the oceans are vast. The amount of plastic is not trivial that's being dumped into them. And therefore, it is easy to overlook how important this is. I do dispute that, but one has to bear in mind that it is the long-term effect of the plastic which is going to be there for a really long time, because nature can't break this stuff down. Once you've got microplastics, very hard to get rid of them, and therefore their environmental footprint is going to be very considerable, and that's why we want to deal with them.
Absolutely. Daniel, thank you very much for asking the question, sir. Let's move on to Debbie and Stellenbosch. Hi, Debbie.
Hi. This is a question that was asked when studying engineering. If you take a glass of boiling water and you put it in the freezer, it's meant to freeze more quickly than if you take a glass of cool water and put it in the freezer. And I now teach engineering, and I can't reconcile that. I've tried to explain it. I understand that with the temperature difference being higher, it will be more heat transfer, but you've also got longer to go. So I was wondering if you could explain it.
I love that question.
Hi, Debbie. I can't remember the name of the Indian gentleman who first proposed this. Someone will tweet me at Naked Scientists, I hope. It's just slipped my mind. But yes, this is a long-standing claim that if I boil some water and I take an equivalent volume of water, which hasn't been made hot, in an identical bucket or pot, and I put the two in a freezer, the one that's been boiled up and made very hot freezes first. Is this true or not? Well, actually, there's a number of reasons why this can happen, why hot water can cool at a faster rate than cold water and freeze. And one of the reasons is when you boil water, if you've got non-pure water, so it's got hardness in it. So if you live around Joburg, for example, and you're drinking water that's got a lot of calcium in it because of the limestone that flanks Joburg, then you're drinking hard water that's got dissolved salts in the water. And if you dissolve anything in water, then you do two things. One, you raise the boiling point. So in other words, you have to make it hotter to make it boil. You also lower the freezing point. So you have to make it colder before it freezes. And any impurity added to water will do that. Boiling removes some of the temporary hardness from water. Therefore, the water that's been boiled will be a bit less hard than the water that has just been run out of a tap, for example, and therefore you would anticipate that it would reach its freezing point at a higher temperature than the non-boiled water, so that might be a factor. The other point that was put to me, which I think is quite an interesting idea, is that when you have hot water, it's got a lot of convection activity. Because something that's less dense rises above something that's more dense, hot water is less dense than cold water. So if you have a bucket or a cup of very hot water, because it's losing heat, it will be losing heat from the surface of the liquid and the sides of the liquid. And as they lose heat, those bits of the liquid get more dense, so they sink to the bottom, and the stuff that's less dense is pushed up to the top. So this creates a circulation in the cup or the bucket. And because the water's got momentum, even though the temperature eventually falls and that effect that's being driven, the thing that's driving that effect goes away, there'll still be momentum and therefore circulation in the cup or the bucket. And because of that circulation, it will enable the bucket to continue to lose heat more rapidly than a cup that wasn't hot in the first place and therefore didn't have the same momentum in the water. That's another theory that I've heard to account for this, but it does appear that there is a kernel of truth to this.
Fascinating as always, listening to Dr. Chris Smith. I'm just looking at the news now, Chris. The fans are upset with the Australian GP being cancelled. But you're going to see this. This is probably going to happen in football. And I also think in Europe, because of the close proximity to each other, people are going to be looking at this as well, cancelling more and more events.
Yeah, it's an inevitability that we realise that obviously moving mass numbers of people and bringing mass numbers of people together is a risk factor if you've got a lot of disease activity in an area, either people coming from an area where there are lots of people carrying an infection who potentially will mix with lots of people who don't have the infection, or if you've got, say, a lot of people getting together who might spread this in some way. But it's not as simple as saying if we don't put people in a sports stadium, they won't catch it, because the other point that was made about this is if you then all go off to the pub and watch it instead, you're just up close and personal in a smoky pub with a whole bunch of people who might infect you there, and you take public transport, etc., to and from the pub. So it's not a given that just not going to an outdoor match, breathing fresh air, is a higher risk than going to a pub.
Yeah, and then you'll get countries that will do absolute quarantines, going, you're not allowed to do this, you're not allowed to do that. If you do go to shops, it'll have to be under these circumstances. Anyway, there are some coronavirus-related questions that we have come through as well, so you can put those questions, coronavirus or not, to the Naked Scientist, Dr. Chris Smith.
Join the conversation.
Join the conversation. You're with Cape Talk.
David in Greenpoint, good morning.
Hi, good morning. What I'd like to know is they advertise all these immune boosting substances. Is there any truth in it? Is there any proof? Is there any point in taking it, or is this just an economic ploy?
Yeah, I think it's an economic
boosters,
ploy.
yeah.
I think you've nailed it yourself. Obviously, there are some things that boost your immune system if you have a problem with your immune system. For instance, if you have a disease that damages your immune system and you take drugs that help your immune system to fend off whatever that thing is, I'm thinking, for instance, HIV, you could regard an antiretroviral drug as an immune booster because it keeps you healthy. But most of these supplements and things like that are just rubbish, and they're just people profiteering out of you. That's what food is for. Eat a healthy diet. You can get all the same things that are in these pills. You'll get them in the context that your body's evolved over millions of years to get them in at the right concentrations in the right way, and you'll be fine, and you'll be as healthy as if you spend precious money on what amount to very expensive supplements that are basically preying on your insecurity to make the only thing that really benefits is the bank account of the people who are selling these things to you.
Now, Chris, just looking at some of the other questions, a corona-related question for the Naked Scientist. Should we limit big events to protect the elderly in particular? You did allude to this earlier, but I think maybe let's maybe deal with that. So events that specifically deal with people that are most at risk, right? Would it be wise to look at those events first and just cancel them?
First point, the entire world population, apart from the 100 and something thousand people who've so far had and either recovered or unfortunately succumbed to this infection, the world population is susceptible to this new coronavirus. So anyone can catch it. And it's very likely that as this goes through the world population, a very high fraction, perhaps 80% of people in this first circulation will catch this. So it is impossible to prevent a group of people in society from catching it unless we put them into some kind of bubble and they are prevented from interacting with the outside world, because that's not how society works. Therefore, given that everyone is susceptible, the best we can hope for is to make sure that we have the resources to help and protect and defend the people who are most at risk. That will probably come in two forms, or possibly three. One is, in the short term, making sure that there are health resources available to help these people who are most at risk when they need it. At the moment, we believe that if we just let this thing go, we're going to get a very big spike of cases because everyone's susceptible, and it will spread very fast, and with time it will spread faster and faster because there are more people giving it to the remaining people who haven't got it, so therefore it will accelerate. If that overwhelms the ability of a country's health service to cope, then we're going to rob resources away from the people who really need those resources to cope with it. So the current aim is to what they call flatten the curve. So instead of a big spike of cases, you aim to spread the cases over a longer period of time so that you never breach the perceived coping threshold of a health service. Now, that will differ from one country to the next, but in one way of doing that is to put in place various measures to slow down the way in which these things spread through society. So depending upon the country we're talking about, or the area, or the region, different countries are going to be different because they have different demography, they have different levels of resources, different levels of population movement, etc. There will be a point where it really helps to put in place measures like what they're dubbing social distancing. So we bear down on schools, we bear down on public events, that kind of thing. The aim not being to stop this, the aim being to slow it down. That's the first point. That will buy us some time. So now we're into points 2 and 3, because with time comes research and research findings, and those findings may inform either our ability to come up with a vaccine, although I'm sceptical that a vaccine can be made in the time that we need it to be most effective, but people are certainly trying. And the other is antiviral drugs. At the moment, people are looking at various cocktails and combinations of drugs, some of which are already on the shelves for treating other viruses, to see if they can find some chemicals which will add some weight to our ability to stop this virus. They haven't found any really convincing drugs yet, but they have found a few that might have some effectiveness, and there may even, with an amazing stroke of luck, be some chemicals we haven't discovered yet that we could find in a hurry, although I'd be very sceptical about that because coronaviruses have been around for a really long time. So at the moment, people are taking a proportionate response, and when the numbers in certain countries reach certain levels, that's when you kick in with more and more of these measures, aiming to put a barrier in the way to slow down the spread of the virus, but no one is kidding themselves that in some way we're going to stop this, because we're all susceptible to it, so therefore ultimately we will all catch it at some point.
Now moving on to Andre in Kales River. Hi there, Andre.
Hello, Kino. Hello, Doctor. Last week somebody called in with a mosquito repellent, or it was the week before, mosquito repellent, which also has a very high frequency feature which chases away mice. And the good doctor mentioned that, perhaps this might be a waste of money. I actually have one of these devices. It's actually a tube which has an ultraviolet series of LEDs around the top and a little fan. And then the mosquitoes are actually attracted to the ultraviolet light, and then the fan sucks them into the tube and it traps them at the bottom, and all the air goes out the bottom through a series of little holes.
Yeah.
That the mosquitoes can't get out. So that works extremely well. And I just thought I'd like just to illuminate, if you...
Yeah. But Andre, that is not
a... It works extremely well.
That's quite different, because we were talking about sound waves. Ultrasound is sound. You're talking about something which absolutely does attract these insects, which is a nice light. And in this case, there's a filter in there to trap them. Other people use a series of electric wires to electrocute them. That's quite different as a way of actually either repelling or attracting mosquitoes. We were talking about specifically sound, and I said that mosquitoes actually use sound to talk to each other and recognise who they want to mate with. One quick point before we go, Kino. I said I couldn't remember the name of the Indian gentleman who discovered the water freezing effect. He was a Tanzanian gentleman, and it's called the Mpemba effect in his honour.
Oh, wonderful. Chris, thanks for that. Always great having you on the show, sir. Have a good week.